Hello, it's Loucks. Today, Eliza, Volk, and I will be teaching you all about the Pascal's triangle for our math video project. Although many mathematicians studied it before him, Pascal's triangle gets its name from a French mathematician named Blaise Pascal. Before we get into what it is and what it's used for, I'll show you some patterns. First, the diagonals. As you can see, the first diagonal are just all ones. The next diagonal are counting numbers, so just 1, 2, 3, 4. The third diagonal are triangular numbers of 3s. And the last diagonal are tetrahedral numbers of 4. And as you can see, the diagonals are the same both ways. Another pattern is the exponents of 11. Each row is the power of an 11. For example, 11 squared is 121. 11 cubed is 1,331. And another way of looking at the numbers is how many possible ways there are to get there. So this is a 2 because from the top you can get there 2 ways. This way and this way. And the 3, there's 3 ways to get there. Here, here, and here. That's just another way of looking at the numbers. Okay, here's some more patterns and another way you can draw the triangle. So if you split the triangle down the middle, both sides are symmetrical and have the same numbers on the right and the left. For example, if you split it right here, the left is 35, 21, 7, 1. The right is 35, 21, 7, 1. Also, the sums of the horizontal rows double as you go down. So the sum of this is 4, the sum of this row is 8, and it doubles going down as you can see. Also, each number is the sum of the 2 numbers above it. So 6 equals 5 plus 1, 28 equals 21 plus 7. So now I'll tell you what it actually is. The Pascal's triangle is a triangular array of the binomial coefficients. And that just means that binomial coefficients are just any positive integer that occurs as a coefficient in the binomial theorem. So what's the binomial theorem, you might ask? The binomial theorem is a fast way of expanding an expression that has been raised to a power, usually a larger one. And here's the formula that shows that. So n to the exclamation point is sort of weird, but it's just the product of all whole numbers between n and 1. And this is relevant because the Pascal's triangle is a way that you can find the value of n, c, k. And I'll show you how to do that next. So, for example, if you wanted to find 6c4, you would find a 6 that immediately follows a 1. So not this 6, but this 6 because it immediately follows a 1. After you find that, you go to the 4th number after the 6. So you count 1, 2, 3, 4. And so you find that 6c of 4 equals 15 using the Pascal's triangle. Thank you so much for watching. I hope you learned lots. By Eliza, Volk, and Loucks. See you soon.